Is it going?
Tell us your name and tell us about your project.
My name is Jason Crenshaw. I did my Capstone Project on measuring the speed of light. We're trying to figure out if the speed of light is infinite or if it can be measured. What the speed of light, what we can do with the speed of light, and well, I'm also interested in what time frame this experiment was taken in, and what I can prove with this experiment.
What were you guys trying to do or find?
We were trying to prove that light was not infinite. We looked in a couple of older experiments and from the past, and we thought these experiments were inconclusive. We wanted a measurement. We didn't want to just say it was infinite and move on. We thought there was more to it than what other scientists had previously come up with. Galileo was the first person to record on record to try to determine the speed of light, and he was not successful. We wanted to prove the theory that light is able to be measured.
Where did the project or experiment occur?
It actually occurred outside, looking up at the moon, the stars. We were measuring the time that it took for the moon to rise and set, and when the stars lined up, and mainly the eclipses of the moon. We observed and recorded the eclipses of the moons of Jupiter. We noted the time intervals between the successive eclipses of a given moon was 7 minutes greater when the observations were carried out. When the Earth was in its orbit, was moving away from Jupiter, then when it was moving toward Jupiter. During the time, the exact distance was not known. So we didn't really know the distance between Earth and Jupiter. We had no way of accurately measuring that. So we were able to disprove, that the speed of light was not instantaneous, and estimate that light travels at around 22,000 kilometers per second. However, this was changed later on in the future with better technology. We thought it might, but we were only 80,000 kilometers per second off the speed of light. The actual speed of light in a vacuum stands at 299,792,458 meters per second. We didn't have quite the technology or the knowledge that these people in the future had, so we weren't able to get a more accurate reading, but other scientists were really impressed with the time frame that we did this. Also, we didn't have the measurements of the circumference of the Earth, so that was one of the readings that we didn't have, but we were pretty close for that time period.
What other significant events were happening around the world at that time?
Well, we proved the light was not instantaneous in 1674. But the following took place: the Netherlands and England signed the Peace of Westminster, and New York City becomes English. The German Parliament declared war on France. Spain, France, and the Netherlands formed the Triple Alliance. Father Marquette builds first dwelling in what is now Chicago. And John Kersey begins publication of the elements of that mathematical art, commonly known or commonly called algebra. So that was going on in our time period.
Who else was involved in the project?
Well, I like to take, all the credit, but I can't. It all started out with a 5th century philosopher Empedocles. He was the first known person to question the speed of light. Questioning the speed of light was infinite. Aristotle later disagreed and stated it was infinite. Galileo was the first person on record to actually experiment it, and he tried to determine the speed of light, but he failed. Dutch scientist Isaac Beeckman in 1629 tried, and his experiment was also found to be inconclusive. Then me and my good buddy, the Danish astronomer Ole Romer, we were the first guys to prove light was not infinite. Then looking into the future, just a couple years later, in 1729, James Bradley came up with the more accurate number that we discussed earlier.
What was your role in the project?
Well, I studied the stars. I kept track of, when the stars aligned, when the eclipses fell, what time of the period, and I took care of the technical data, I guess, too, and also tracked the distances between the planets, and the precise times that the stars align, so I could get all these accurate details of when and where these solar eclipses would take place.
What impact did your project have on the physics community?
Well, it gives us a constant of speed to be able to measure the distance, to be able to measure the speed of an object. The speed of light is the only speed that is independent of the observer, and it is absolute. No object, no matter how strong the forces acting upon it, can ever be accelerated to the light of speed.
What interested you most about this project?
What interested me most about the research is that by watching the moon and the stars, you could actually come up with something that is going to change the world. It's a theory that that this project will be in everything we do, from measuring how long it takes to get somewhere, to how fast the Earth rotates, to how long it would take for an army to get to our position. It's a constant that cannot be changed, and anyone can use it. That's my Capstone Project. Thank you for watching.